All right, so welcome to another episode of KodeCamp. Like I said, we're going to talk about CI/CD. CI/CD is a very, very vital concept in our quest to be DevOps engineer. You cannot be a DevOps engineer. In fact, CI/CD is the foundational, outside the foundation. So we already laid the groundwork, which is to build the foundations. Now, what we're doing now is we are raising the house above ground. You get, we're raising the house above ground. So, yeah, so we'll talk about CI/CD. Now, what is CI/CD? Basically, CI/CD is the encompassing what we refer to as the entire software development life cycle is what we refer to as CI/CD. Is what we refer to as CI/CD. You know, it's um it's very, very important concept, that helps in the movement of software from your local machine to anywhere you want to deploy it, and in an automated process. You get. So the first thing we have here is plan. Let us look at this to first of all understand the software development life cycle we're talking about. Software development life cycle. First thing, we have plan. So the first step you need to do in this case is to properly push software to wherever you want to push it to. You first of all have to plan. So plan is like a very, very integral concept of CI/CD in general. You understand? When you plan, then the code. So, okay, so it's integral concept of software development lifecycle. I think I explained it in the first class. The first thing you need to do is to plan. When you are building software, a plan is the first step that we need to do in order to please confirm you can hear me. My network is misbehaving.
Can hear you, sir.
Okay, so now after the planning phase, the planning phase is the place where you talk about the software, talk about what is involved in building of the software, that kind of thing. That's what the planning phase is. Then after the planning phase now comes the coding phase. This is where the developers work. And then this is where developers work, to write the code according to the plan, you know, to write the code according to the plan and ensure that everything works as expected, basically. Then after the code phase, you now have the build phase. Now, this build phase is where you compile the code. So where that code that you have written, you compile it into a very, 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 runnable instance. Like when you have packaged the code together, it's able to run. That's the build phase. Now, the test phase is now the place where you ensure your build meets quality standards. You understand? So you cannot be a good developer or a software engineer or a DevOps engineer if there is no proper testing in the code. That's why there's a test phase. You get. Then there's the release phase. So the release phase is now where you package your software for release. That release now is what is being prepped to get into the market. If you're talking of like in a factory setting down, the release phase is the point where you put your cartons, you put your goods inside carton, you put your goods inside carton and you put your goods inside carton and put inside the delivery van. That's what is like the delivery phase. That was the release phase rather. Then there is the deploy. So deploy to production environments. Deploy to production environments. That deploy now is where it gets to the final destination. That the server that you want to put it. Sorry, my background is doing somewhere to bring it. Which is either the server that you want to put it or the um the Kubernetes cluster and all those things. And just basically the area where you want to put the application, like deploy the application basically. So that's what the delivery phase does. You understand? But now the operate. The operate is now where you manage the software that's released. You ensure that there are no bugs in the production, you ensure that there are no users complaining, you ensure that your server utilization is normal. All those setups is what is in the operate phase, basically. So that's what is in the operate phase, basically. Now, monitor is the last phase. Monitor is the last phase. Monitor is the last phase where you will put in systems that ensure that you can get feedback. So monitoring is basically getting feedback from the running of the system. You understand? That's basically what monitoring is, getting feedback from the software as it runs, the amount of users, the amount of CPU utilization, the amount of resources that the application is actually using. So it is in the monitoring phase that you can determine, oh, the traffic is high, traffic is low. Let me increase the number of servers. Let me reduce the number of servers and the rest. So, yeah, so this is the phase that you get those stuff done. Now you can see that there are eight phases. There are 8 phases in this whole setup. There are 8 phases in this setup. Now, so normally, traditionally, yeah, this is what a software engineer goes through on a daily basis. You get traditionally, this is what a software engineer goes through on a daily basis. They have to first of all plan. They have to first of all They have to first of all plan. They have to first of all write them down. After planning, they write the code. They write the code. After writing the code, they build the code. After building the code, they test the code. After testing the code, they now prepare it for okay. Monitor is basically like the setup system. It's like a watchdog, basically. So when your software is online and running and users are testing, you set up monitoring systems that you can be able to determine certain stuff on the setup, like, oh, is my software are the users. Yes, this is where CloudWatch. This is where CloudWatch comes in. Exactly. This is where CloudWatch comes. But CloudWatch is just one of many. And CloudWatch is just basically for AWS. So you're integrating it with if your platform is running on AWS, that's when you now integrate CloudWatch. But there are some other tools that are vendor agnostic, meaning that you don't really need to on AWS. You don't really need to be, you have resources on AWS to run them. You can run them wherever your resources are. There are tools like Prometheus, Grafana, Elasticsearch, Logstash, Kibana. There's now this CloudWatch for AWS. There's Azure Monitor for Azure, and there's GCP monitoring in Google Cloud, that kind of stuff. So it all depends on what you're setting up. But as usual, whenever you deploy an application, you set up monitoring to be able to get information of that application. Because the monitoring now that will alert you when, oh, this particular system is down, or check it. I had a situation recently in my workplace where the cloud front that they set for the servers, it went into 502 error. And I had set up, we were able to discover it on time before the client, because I had set up a system where whenever any of the CloudFront distributions get a 502 error, which is, server-side error, it should send us an email, send all the people in the IT team an email. So I was the one that configured that. And once I configured it, everybody was abreast to the situation before the customers complained. So once they started seeing the emails popping in, they rushed out immediately. I started solving the issue. The issue was from one of the servers that were running. The server was having a high throughput, so we had to scale the server. Sorry, now I'm talking too much big English. We had to scale the server, add more storage and more volumes to the server, so that you're able to, manage the amount of users coming in before the thing came up. When the thing came up, we did not see the email again. So that is basically the littlest level of monitoring that you can implement in your system. So now, as a software engineer, you see that you will get to implement all this. Imagine implementing planning, code, build, test, release, deploy, and operate and monitor at the same time, back to 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 back. Every day you're planning, you're coding, you're building, you're testing, you're releasing, you're deploying, you're operating, and you're monitoring every single time. You'll get burnt out, to be honest. Really burnt out. That is where CI/CD comes in. Now you can see CI/CD is what? Continuous integration and what? Continuous delivery. Continuous delivery, continuous delivery. So these 8 pillars of a software development life cycle is continuous. That is what continuous integration and continuous delivery is. These 8 pillars. So with one single system set up, you can plan, you can code, you can build, you can test, you can release, deploy, operate, and monitor with one single test setup. And then when one part of the setup fails, you can easily roll back. For example, I write the code. The code is not part of the plan. You can easily adjust back to the plan to find the plan and continue writing the code. Now, I write the code, and the code, you want to build the code does not build. You can easily fall back to the code and adjust the code. Then I write the code and the code builds. But you write the test is failing. You can easily go and adjust the code and the build. Then the test will pass. Then the release is probably failing. You check the test, you check the build. Then the release will pass. Then you deploy. Sometimes when you deploy, deployment will fail. You check the release, you check the test, you check the build, you check the code. You also check the plan if it makes sense enough for the release scenarios. Then after that, you deploy. After deploying, you operate. Now, while you're operating, this is where the users will have interactions with the software. Once the users have interaction with the software at this point, that's where you now monitor. Once you monitor, you see that, oh, there are some certain things that are going wrong. That's where you now go back to the code and then adjust. This is where you now have a different version. That's why you see things like, version 1.2, version 1.3. So by the time let me say you deploy version 1. By the time you deploy version 1 now, after deploying version 1, you see that, oh, there are some feedbacks coming in. Feedbacks doing this, feedback doing that. They should implement this. That's why you now go and launch version 1.2. Version 1.2 now, you write the code, you build, the same build though, you write a new version of the code. So this is where your GitHub, your Git knowledge comes in. You write a new version, then you build, then you test, you release a new version. So it comes in as a new version. I know when people were doing what they call it, Docker, people just use latest for the image, latest. But in production situation, you don't use latest for image, you use the version. So that is that part where you see 1.0, 1.1. You release it as a new version 1.1, then you deploy it as it now goes to your server as version 1.1. Then you operate. When you now operate, then it is now released as a version 1.1 as a newer upgrade to the public. Version 1.1 of this application has come out. Then you continue monitoring. So if something happens now, for example, version 1.1 has issues, so let us go back to version 1.0 while fixing 1.1. You go back again, you change the version in the release to 1.0, deploy again, operate. When the operator now, the user starts seeing 1.0 again, then you monitor. You keep on monitoring. So this you keep on watching. Oh, it's like the last mile of the whole system. Sorry to use that word for those staying in Lagos. You know, you keep on watching. Oh, this is this. What is software? How is the software reacting to this? Blah 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 blah. You keep on watching. You keep on watching. When it's now stable, the stability now. Once it's stable, now you can always get feedback. You get feedback on it. Oh, add this, add that. That's where you now do what? Version 2, version 1.3. Now I'll teach you semantic version. I think before we do our hands-on on Friday, I'll teach you what semantic version is. So you understand how the version better version your application. You understand? Before we do hands-on, I'll go through what semantic, we call it SEMVA. SEMVA is semantic versioning. It will be ideal. And then after semantic versioning, you will have to use it in the next tasks, because next tasks will also involve Docker and CI/CD. But that being said, just prepare your mind. Now, so that's what CI/CD is basically in the high level. You get in the highest level. That's what CI/CD means. So now let us explain what is CI/CD. There's CI. CI means continuous integration, automatically building and testing code anytime it is pushed. Then the CD means two things. It's supposed to be continuous deployment before continuous delivery, but it's a mix-up. So continuous deployment first. After continuous integration, continuous deployment first. Continuous deployment automatically deploys every change that passes the pipeline. So this whole setup now, if you go back now, this whole setup now is what they call a pipeline. This is a pipeline. A pipeline. So when you say, I beg, make I just build this pipeline, make I use deploy this code, you'll be hearing things like, I say, well, that pipeline don't break. It's like a lingua franca in the DevOps industry or in the DevOps world. Oh, this is a pipe. So when they say build a pipeline, this is your blueprint, basically. You understand? In most cases, the developers will mostly just do the planning and the coding. You get, and then probably locally build and test to ensure that it works. But you are running this whole thing. So let's just say that you're not the code savvy DevOps engineer. Your tasks just probably start from phase 3. You will build it, you test it, you release it, deploy, operate, and monitor. But like I said, if you're running the entire thing, you start from here. Some companies will not employ you as a DevOps engineer if you don't know how to code. But like I said, it's not compulsory, but it's nice to have. You get, most especially Nigerian companies, most of them they want to use you, so to say. But anyways, yeah. So yeah, let's go forward. So this is now continuous deploy automatically deploy using the passes the pipeline. Then continuous delivery. Ensure that the application is always in a deployable state, meaning that at every point in time, it should be ready to be enter. Your version should be ready to enter production. That's what continuous delivery is. Always ensure that there's an application that is in a deployable state. Yeah. So now, why was CI/CD introduced? Let's start from there. Why was CI/CD introduced? CI/CD was introduced because of what? There was a manual and fragile process. There was a manual and what fragile process. Developers built, tested, and deployed code manually. It was sad. Really, really, really sad. I can explain before. You will build, you will test, you will plan, code, build, test, the release, kini, everything by yourself, manually. Now, this led to inconsistencies, forgotten steps, and worked on my machine issues. Because you will write a code and you will tell yourself, oh, this code is working on my Windows 10 computer. Okay, let me not use Windows. This code is working on my Ubuntu 20 or let me use Windows 10. Let me work in my Windows 10 computer. You now give it to the operations team. Operations team is using Windows 8 or even a newer one, Windows 11. What will you do? What will you do? You complain, oh, it works on my machine. You have to ensure that it also works on the other guy's machine too, which is now a roller coaster. A very, 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 very solid roller coaster that you cannot deal with. So that is what how I was trying. Then there was now slow, risky releases. You'll be seeing deployment happen every few weeks or months. For example, now, once a user complains, oh, XYZ is happening, you have to now schedule a deployment. You understand? Because you cannot be deploying every day because it's a manual process. And that's what, sorry to say, that's what some of these banks use. You know, some of these, all these are banks. A lot of banks have not fully adopted DevOps processes. So they use traditional deployment, which is slow. That's why they don't respond to your feedback on time. They take a while before responding to feedback, which doesn't make any sense. You understand? The longer the release cycle, the bigger the changes and the more risk involved. So, because at every point in time, there will always be a need for change. And when there is no automation to these deployments, the changes will take longer. And the more the changes take longer, the more changes start coming on board, which does not make sense. So CI/CD was built as a response to this. You understand? Then delayed feedback. Teams wouldn't know if something broke down until much later. This delayed discovery causes wasted time, more debugging, and unhappy users. That is why CI/CD came up. You can see now, you can see from the image, you see the dev, you see the ops, you see the system has caught fire because there's no synergy between this whole setup. Yeah, so that's the main reason why these three reasons are the fundamental reasons why the concept of CI/CD came on board. Now, benefit of CI/CD, speed and efficiency, number one. Like I said, changes are integrated immediately and can be deployed automatically. You understand? Changes are implemented immediately and can be deployed automatically. Teams ship features faster and more frequently. That's what CI/CD does. You understand? Then there's automated testing equal to fewer. Sorry about that. Someone's opening gate again. Automated testing and fewer bugs ensures that every change is tested. So for every change that you put inside your application is tested. No more surprises in production. Then reduced risk of introducing errors. Reduced risk of what? Introducing errors. So in the production setup, once it is properly tested using the CI/CD pipeline, there is a reduced risk of having errors in your application. Companies that don't adopt DevOps practices, they end up seeing, so solving errors is more reactive than proactive for them, which is a very, very, very bad practice. Then there's continuous feedback. Developers get instant alerts when something fails. This promotes faster fixes and what? Better code quality. Then there's repeatable, reliable deployment. No more, it worked last time, or I forgot to run that script. Pipelines are deterministic because you know what happen. The state of the pipeline is always steady. You get. So you may, for example, now you as a human, you will always make mistakes. Imagine going from step one, two, three, four, five. You may forget step six and seven, go to eight. You may forget five, go to seven. You may forget two, go to three. But when you set all these things in a pipeline, it goes like that, the same way till the end. It doesn't stop. Now there's reduced stress on engineers. Smaller automated changes means less pressure, fewer outages, and late night firefights. People have seen firefighters before now, trying to put out fire. That's exactly the same way that DevOps engineers and cloud engineers do. Your app, if someone might probably just buzz you in the night when you're with your family, oh, our app is down, oh, come and solve this issue. And then you now start trying to, trying to troubleshoot, trying to it doesn't make any sense. So yeah, DevOps is not just a buzzword. CI/CD creates shared responsibility. So yeah, the responsibility is shared between the developers and the engineers, ensure that there's proper synergy across board. So yeah, now there's traditional workflow versus CI/CD workflow. Now, traditional workflow, manual build and test. CI/CD workflow, automated with every push. Now, there's infrequent risk deployment. Now, there's small, frequent, and safe releases. For traditional workflow, there's testing done at the end. This one, testing is continuous and automated. That explains itself. Then there's hard to roll back. Hard to roll back broken features. Hard to roll back broken features. And they're easy to trace and roll back via pipelines. Dev and ops work in silos. And then there's shared ownership and what? Collaboration. Debugging is reactive. What is reactive? Reactive means this when an action has done, an action has occurred, that's when you now want to do your own acting. But CI/CD workflow, you fail fast and fix early, meaning that your actions is proactive. So yeah, is there any questions so far? Is there any questions so far? Any questions so far? Don't come and be asking me in week 10. Oh, that's the ICD. I don't understand it. Oh. Ask your questions if possible, if you need to. Please. Okay, oh, everyone is quiet. No problem. Let's move forward. Um, Now there are different CI/CD tools. Like our usual routine. Our usual routine. We always tell you all the options that you can choose from. We have done it from Ansible down to now. But we will now stick with the one that is relevant enough to help you break into the field. You must not learn all. You can just have an idea of, but you have to be grounded in one. And that one that is grounded should be the one that is widely recognized in the industry. Like 70 to 80% of industry players use it. You get. First one is GitHub Actions. What we'll be focusing on today. The good part of GitHub Actions is that it integrates very well with GitHub. So everybody here has GitHub repos. You won't tell me you have GitHub repos, you can literally done projects on GitHub. Now, GitHub thought it wise that instead of having a GitHub repo and then going to set up CI/CD elsewhere, which was the case initially, you know, that kind of 2020, 2021, 2019-ish, you have a GitHub repo, but you're not going to start ending up setting your CI/CD elsewhere and connecting your GitHub repo to it. So it just pulls the code from the GitHub repo into the environment, into the CI/CD platform, and then from the CI/CD platform, it now sends the code to wherever it wants to go. Now, GitHub thought it wise adds a CI/CD inside their platform, which is what they call GitHub Actions. I'll be doing a walkthrough after the class, so we'll see. We won't rewrite code today until our hands-on day. The hands-on day, as usual, I'll give you a snippet. Like I said before, that Dream Vacation app that we did, we're going to use it for CI/CD as well. So if you know you did not do that assignment, you can do it too, because here I'm going to catch you people. So go and do your assignment because you continue from whatever you set up in that CI/CD in that assignment onto CI/CD and for other projects that are coming up as well. For like the next 2 projects, that's what you will concentrate on. So yeah, easy setup with now integrate directly into GitHub Action. Easy setup. Now to set up your GitHub Actions, the only thing you will need to do is to define a folder. Once you want to set up GitHub Actions, you set a folder called .github in your code, on your repository, on the folder where your code is. You set a folder called .github/workflow. So the workflows folder will be inside the .github folder. Then inside the workflows folder, you now define whatever you want to define, like front end or YAML, back end or YAML. For example, now your code is a monorepo, like Dream Vacation app. You said same way you did it before. We had folder, front end. Now, one thing with GitHub is that you have to set GitHub at the root repository. For those that did that last assignment, the same place where you put Docker Compose or YAML, that root repository, that is where you put your GitHub. You go put your GitHub definitions inside files. You don't put your GitHub definition inside files. You put your GitHub definition, inside folders, inside the repo, inside the document. For example, now the way we have backend and frontend, when we're doing Docker file, you put the Docker file inside the backend folder, put another Docker file inside the frontend folder. You don't do it like that for when you're defining workflow. You put it at the root, at the beginning. So you have .github, front end, back end, and then the rest, probably README, Docker.compose or YAML and the rest. So the first thing you have .github. Inside that .github, you have workflows. Inside that workflows, you have front end or YAML, back end or YAML. If you are trying to deploy infrastructure, you're not deploying code. Terraform.yaml. If you're trying to deploy monitoring script, monitoring.yaml. If you're trying to deploy an Ansible configuration, because you can't use CI/CD to deploy Ansible configuration, you do Ansible.yaml. You get, that's how it works. Then it supports CI, CD, testing, Docker, secret, environment, etc. I'm going to do that. Ideal for open source, personal projects, startups, and GitHub native teams. So your team has this entire application on Docker on GitHub. GitHub is the best. GitHub action is the most preferred because it's very, 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 very minimal to configure. You don't need to do all those configuration. And one thing in GitHub is that you don't need an agent, and so you don't need all these hosts. You don't need hosts as well. You just, once you have a repo, you can just deploy it there and then do your stuff. The only way you will need a host is if you're trying to run a self-hosted runner, which that's more advanced. Now there's GitLab. Now GitLab is also a code GitLab is also a code repository. GitLab is also a code repository like GitHub. It's like a direct competition. So it's the same thing. Once you host your project in GitLab, you now that has this DevOps feature where you set up, and once you set up, you can now run everything. It is great for monorepos, Docker, and full DevOps lifecycle. The same thing. Now, the same way you do, but this time you don't deliver it, you don't put it as a folder. You just specify a file, the same place where you did Docker Compose or YAML. Just specify .gitlab/ci.yaml. You get. So once you deploy the code to your GitLab repository and you click on actions, you want to deploy it somewhere, it will read by default, it will go and read where GitLab ci.yaml is. Same thing with GitHub Actions. Once you click on actions, to go to where GitHub/workflow is and look for the YAML file inside there, and that's what it's gonna use. So yeah. Yeah. Hold on. So then there's Jenkins. Like I wrote there, the OG of CI/CD. Jenkins, Jenkins ran so that GitHub Actions and GitLab CI could work. Because when I mentioned, or rather, I didn't say the opposite. Jenkins worked rather so that GitHub Actions and GitLab CI could run. That's the right one. Because when I mentioned that whole scenario first, where there's a CI/CD pipe platform, then you have to connect your GitHub. Then from that CI/CD platform, you now start doing all the integrations to deploy to anywhere you want to deploy. That was Jenkins I was talking about. Jenkins is difficult. And Jenkins, let me tell you the truth. Jenkins is fabulous when you know it very well, but the learning curve is crazy. I'm not trying to badmouth them, but if you know it and you can use it, you will enjoy it. But it's good, but number one, it requires self-hosting. So you have to you have to build it by yourself. So you have to get a server, install Jenkins. When you install Jenkins, you now have to run it. Now, when you run it, sometimes there might be compatibility issues. So you'll be seeing error in some places. When you manage to go through that, you now have to think of how to create a webhook that will go and hook the GitHub Actions that you want to get the code from. When you hook the GitHub Actions, you have to think of how you will now integrate AWS that you will now you're deploying to. All those setups were crazy. And initially, when I said DevOps, Jenkins was what made me fear CI/CD real bad, because the configuring process is not here. And I intentionally did not take any project that had to do with CI/CD. But anyways, it's still good. It's the OG of CI/CD. In fact, prior to lockdown, There were other tools, but prior to lockdown, Jenkins was when you say, oh, I want to do the pipeline, it's Jenkins. I think GitHub Actions and GitLab CI came around 2020, 2021-ish, 2019-ish. But the OG that has been there has been Jenkins. Like I said, open source and highly customizable. It's very customizable. You can, like I said, you have to install it by yourself. You have to either install it in a Docker container or you install it on a server, and it needs like 4 gig of, 4 gig of memory and all those things, 4 gig of RAM and all those setups. Self-hosting, it requires self-hosting and ongoing maintenance because you are thinking of how to deploy an application. You're thinking of the stability and the operations and all the monitoring of the application. You're also thinking about the setup that Jenkins is running on. So while you're thinking of the application, you're thinking of the CI/CD at once, which GitHub Actions and GitLab CI came to eliminate. So you don't have to think of what is powering the GitHub Actions. All you just need to think of is your application that you have worked with. So with GitHub, with Jenkins, you have to think of both the application you deploy and the server that's running your Jenkins. You have to monitor because the Jenkins is down. In as much as your server, your application will be working, that pipeline will be cut short. Just like in as much as your car has crossed from one bridge to another, if that bridge collapses, you cannot cross back. So that's what it is. That's the issue that people had with Jenkins. Again, that's why we're talking about GitHub Actions. Now there's CIC, there's the less talked about ones, which is Circle CI. Circle CI is great for cloud and self-hosted project. It's fast. This has strong caching support, YAML configuration. So the same thing too. You want to do the Circle CI/configure YAML. You have Travis, same thing. It is fading away in popularity. Travis is like, all those old takers that still like to make noise. Sorry to use that word. That's what Travis is. You felt like you were popular at some point, but now you're not popular again. But you still want to just make noise in the market so that people will know that, oh, you were once popular, but you're not popular again, but you still just want to maintain relevance. That's what Travis is. People hardly use it, but they're still just trying to dog it out in the market. I pray that you survive. Bitbucket is also like a repository management system like GitHub and GitLab, but it's less popular. Yeah, so like I said, best suited for teams already using Bitbucket as their source control. Yeah, same way you deploy to GitHub, same way you deploy to Bitbucket. It's also a source control. You can check it out. Then there's Azure DevOps. Azure DevOps is strictly for the Azure ecosystem. There's also AWS code pipeline. I didn't write it here. Honorable mention. Azure DevOps is a very fantastic tool. The only downside is that it only works well. In fact, I won't say well. It only works when you're trying to deploy to an Azure related environment, like an Azure virtual machine, Azure Kubernetes engine, Azure App Engine, all those stuff. That's when it works. But it's fantastic. Azure DevOps has its own source control, which is its own GitHub environment. You can do your source control. It has its own Kanban setup, which is where you can do your planning. So Azure DevOps practically summarizes the entire DevOps lifecycle. It has its Kanban setup where you can plan your projects. After planning, you write the code. After writing the code, you now also deploy it to an Azure repo. Inside Azure repo again, you now from Azure repo, you write the pipeline. After writing the pipeline, you also now deploy it on Azure pipelines and all those stuff. So that whole setup is inside the Azure DevOps pipelines. So yeah, the different CI/CD tools. But yeah, like we said, we're talking about one rules, which is GitHub Actions. GitHub Actions. So yeah, what is GitHub Actions? GitHub Actions is GitHub's native CI/CD and automation tool that enables you to automate anything from testing to deployment to sending Slack messages or triggering workflows in other systems. Why use GitHub Actions? One, no need for external CI tools if your code is already on GitHub. Simple. GitHub is the biggest code repository in the world. Biggest. I feel like this was even what killed and what blew up their market, because tell me why you tell me I will deploy an application to GitHub. I will not still be thinking of how to go and install it and configure Jenkins. Doesn't make sense. So when they introduce this action, boom, it blew up, because once my code is on GitHub, I can just initially automatically just create an action and my CI/CD systems work initially. Built-in support for CI/CD and automation. Strong ecosystem for pre-built actions in the GitHub marketplace. So now, when I say actions, actions are set up that you can integrate into your pipeline. So for example, now if you cannot write the code to deploy to, let me say, deploy a Node.js application, you can go to the marketplace, look for a marketplace code, integrate it, and you can use it. Easy to start, yet powerful enough for production system. GitHub Actions is powerful, really, really powerful, and you can use it. That's why nobody even uses Jenkins, but Jenkins is still relevant though. Jenkins is not like Travis CI that is trying to make noise. Jenkins is still there. I call it the OG. Jenkins is the OG. People still use Jenkins, but for modern applications, where you will see Jenkins most is all these banks and institutions that deal with finance, data, big data, and all those kind of setup. They use Jenkins because it's like the reason why they use Jenkins is probably because of that setup where they have to configure their Jenkins infrastructure, so they know that it's within them and the rest. But I think GitHub too is also trying to run that kind of setup as well, because if they succeed, then GitHub Actions will become the market. So yeah, what's to try. Anyways, key components of GitHub Actions. We'll look at this when we're looking through the stuff. You see workflows. Workflows is defined in the now the workflow, that part where you see front end or YAML, back end, they are called workflows. They're defined in the .github/workflow directory, written in YAML, triggered by events. There's what they call events. So there's a push event, a pull request event, a schedule event, a manual event. Can include one or multiple jobs. Now, this event, you can set it that your pipeline should trigger on push. So once you push the application, that thing that you did, where you do git push that origin that kini push. Once it pushes and is successful, the pipeline should run immediately. Now, there's also sometimes you want to push, and then you want to push, and you push things, and then you create a push. So once a pull request is created, then when the pull request is created, then the pipeline should run. Then there's also merge as well. Once the pipeline is merged to main, you can set it that way. For example, now you have a dev pipeline. Once the dev pipeline is merged to main, it should run the pipeline code. All those things are what they call events. And number two, events are what trigger a workflow. You can see push, run workflow when code is pushed to a branch. Pull request, run workflow when a PR is updated or opened. Schedule, cron-like syntax for running periodically. This schedule now, for example, you have a particular deployment that you want to be doing every 6 hours. You can put it on schedule. Same way we had cron jobs. Remember cron jobs when we did Linux and Shell? Good. That's why it's good to pass through foundation. People need to thank me. Thank me very, very well. Please. That's by the way. Schedule. Cron license. Now there's workflow dispatch. Now workflow dispatch. People use workflow dispatch mostly in testing, because workflow dispatch is if you are the one that will trigger the workflow to run. So most people, I use workflow dispatch a lot, but in production systems, because sometimes I don't just want to beat on push, because sometimes you may make mistakes, and then you want to now probably correct the mistake, but by the time you correct the mistake, you put it on push now, it's already started building. So workflow dispatch works for me personally, because I can write multiple things and push them. They now run the trigger once and then it will now run once. Because if you have push now, if you put it on push, if you write first code and drop, second code and drop, third code and drop, that's already 3 builds already. You are burning resources on your runner. You get, but it depends. Oh, they all depends on people that they know what they need to do. Now, this is an example of a pipeline. You have his name, you put the on. So this on is what triggers the event. You see on push, it may not even be in a square bracket. Then you now see jobs. Jobs is build. This build is a name that will give it. Now runs on. This runs on now, it is the runner because like I said, when we did Jenkins, like you said, you set up the infrastructure. But with GitHub Actions, GitHub Actions set up the infrastructure for you by creating an Ubuntu server within itself that helps you to run the. So that means you are not the one maintaining the server. You're not the one maintaining the server. It is um it is GitHub itself that's responsible for that. Let me just drink water small. So you're not the one maintaining a server. Ubuntu latest means that you pull out the latest Ubuntu image and use it for the server. Then there's the steps. So these steps now is what determines each particular action that you want it to do under this build. Then let's go to the next one. There are jobs. So jobs is a workflow is made of jobs that run parallel or sequentially. Each job in its own environment, VM or container. You can pass outputs between jobs. You can see there's job, only just one, jobs. Then there are multiple jobs. There's a test job, which you run here. Deploy job. Now, if you see inside this deploy job, you will see needs test. So this job now is called test. That means before this deploy job will run, test must have finished. And if test does not pass, this one will not pass. You can see, so if you want to run a pipeline sequentially, build, test, deploy, monitor. Put test, we need build. Deploy, we need test. Monitor, we need deploy. Set them up like that. I'll show you. Then steps requirement that makes up a job. Each steps run a shell command. Shell again as come, thank me, or an action. Can use third-party actions or write your own. Runners, the environment where the job runs. This is this Ubuntu latest. You can run it, you can host hosted runners Ubuntu. Please always use Ubuntu. Mac and Windows are difficult to set up. You can also use self-hosted runners where you can install the GitHub runner on your machine and then run it. But this one also, you need to also be very careful as well because there are still some extra configurations that you need to do, but it's not as complicated as Jenkins. So yeah. Then there's the secret. So secret is where you store sensitive values. When you're doing your assignment, this is where you're going to store your Docker personal access token. You use secrets. And then you access it you use this $ curly braces secrets.api key. Because imagine you store the name of API key, you can reference them here. So yeah. Any question of the day? Okay, so now let's do this anatomy of a GitHub Actions pipeline. Let's go back. So this is my GitHub Actions pipeline. The typical example is just for reference only. Don't go and look at it. Now, you can see I put CI. I'm deploying just one application here. I did the CI and CD separate because they were long, but you can do them. You can do them the same file. That was my personal preference. Now, you can see the name is application CD. On push, When you push to branch deployment, you can see I'm in deployment branch here. There's main deployment integration. So anybody that pushes to deployment, that is when this job should run. On push branch deployment. You can do on pull request to branch deployment. Now you can see jobs deploy. Let me go to this first one first. This is the beginning. On push to branch, on push to branch integration. This integration. So once somebody push to branch integration, it should build this. Now, like I said, don't the pipeline is very, very messed up because it's for learning purposes. But when we are doing hands-on, write a proper pipeline. Like I said, now this is push. And this is build and push. That is the name. Oh, this is name. Oh, name. Now, as you can see, runs on Ubuntu. Runs on Ubuntu backend. Steps. This is one. This actions now check out. So it's like checking out to this integration branch. You know that thing when you do it's trying to do that git checkout into the branch that you're specified here with integration. That's what this is. Then now see log in towards Docker Hub. Now use Docker Hub. Now you can see I set my Docker username and Docker secrets inside a secrets folder. Let me check. Let me go to settings. I'll still come back to this. If I go to you see secrets and variables, actions. You can see there are a lot of them. There's GitHub token, there's GitHub username, the Docker Hub username, Docker Hub token. So your Docker Hub username, you store it here when you do repository secret. The Docker Hub token, I'm sure you generated a token from the last class. You store it here. So when you're now referencing it, it's here you now reference it. You come here and reference it here. So you log in. So this is the action. And this is the marketplace action for Docker login. You don't need to start building all the setups again. One good thing about Docker login, unlike if you're in a normal traditional server, you have to first of all install Docker on the server. After installing Docker on the server, you now do Docker login. No, this particular action alone has automated that installation for you. All you don't need to do is now log in. So once you log in, once you now put it now so with username, put the username password. So this particular setup now will log into Docker in your runner, on your GitHub runner. Then you now see build and push front end. Ideally, like I said, this is not ideal. You have to create front end and back end. Front end and back end. I think we'll do that because we're doing back end and front end for that assignment. So I'll show you front end the same way I showed you last time. Do that proof. Now you see working directory dot front end. Now it is going to this front end now to start building. You can see inside front end now, there is Docker file. There's a Docker file inside here. So you see Docker build-t username / challenge front end. That's the name of the image that was the challenge front end. Then you see GitHub. So now instead of you to use later, use the GitHub SHA. Use GitHub SAH. Now it's like the encoded ID of the particular image. The ID of the image. That's what we're going to use. You now push it. You push it now to Docker Hub. Since you're already logged in here, you can push it. Build and push backend. Working directory / backend. Build and push. Now update Docker Compose. Now it is going to come with permission here. If you check here, we have this permission. This permission means that let this workflow be able to write in my code, be able to modify something in my code. That's what this content rights is. And that's what you're going to do as well. Build push. Now update, you can see sed Linux command. Ensure image tag. It's going to look for place where latest is. It's going to look for a line. See this line now, this first line. It's going to look for this first line where latest is. Username or challenge or backend where latest, and then update it with the same Lucas username / challenge backend GitHub sha. We're going to update where GitHub sha is, the GitHub ID of the image. Then that's in the Docker Compose or YAML. You can see the specified Docker Compose or YAML here. The same thing you do here for the front end. Ideally, you're supposed to split it into front end and back end. Ideally. Then this one is if the changes were made, you now push. So how will I put it? This particular setup now, we are pushing back the changes. For example, now, like you said, from this point now, we are checking out into this branch. So we are working in the, we are pulling this, our code base into the runner, which is the Ubuntu latest. So now when we make this change, we're now going to push it back into this GitHub repo. So that's what this change is now. If it has updated as the status has changed, then config username, config, then add Docker Compose, commit and push. I mean, it's pushing it back here because all these changes will be made inside the runner. That means pushing it. That means if you come here now, you can see, I don't know if this particular stuff worked that time when I was trying it. But let me see. Now you can see my SHA, my ID, challenge backend. Initially it was latest, but after running the whole code, it now came and updated this to the ID. So this is the ID now that should go. So if I check my Docker Hub now, this ID now that was on the image for my Docker Hub to now go and pull it. So whenever I put this Docker Compose file, it's going to pull the image with this particular ID, which is like the latest one. So for every new change I make, for every new addition that I make, this is equivalent to if you don't want to do the versioning, but versioning is always ideal though. For every new change that I make, you're going to make a new version with a new ID. I'm going to update the ID here. Once you update the ID here, wherever you're running Docker Compose, it will now run the updated image for Docker Compose up. I don't know if you understand. So that's just the same thing. So now this is for integration, basically. Then deployment. Deployment is also now that for the integration now, for this integration now, the Docker Compose file has been changed to reflect the new, what they call it, ID. To reflect the new ID. Now, you now do runs on Ubuntu latest, check out again. Now you can, because I was deploying it on AWS server. AWS server will need access key and secret key, which I stored in what? The secret inside my settings. Then I set up SSH. You know, get the SSH key. So my SSH key from my server, I got it and also put it in the secrets as well. I configured the permissions, properly. Then I found the EC2 public IP. I went to pull it out. I used the code run. That's why I say knowledge of shell is important. You run this IP, run the code, find the IP address, to display the IP address in the next step. Found IP address. Now copy file to EC2. Now that my Docker Compose is complete, I now copied the file with my Docker Compose into the server that SSH inside. You can see Ubuntu at instance IP/DevOps project. So it's going to create a DevOps project for me inside my server and then run Docker Compose. So you can see SSH into this kini CI/CD DevOps project. Now Docker Compose pool. Now this Docker Compose pool is going to pull these images. Once I've transferred them to my server, it's going to pull these images into the server and then run it. And then Docker Compose up-d. So the deployment will run successfully. Any question of the day? That's how a typical CI/CD. I've not done for monitoring. I didn't do for monitoring for this. I just want to show you how the deployment pipeline is. So for any code now I push, once I push it, all these steps run automatically. Once I push it, all these steps run automatically. Like that, like that, like that, like that. Like that. That's how I'll push code. If I refresh my server, you see the new version has appeared. Because all these steps I just explained now with saliva in my mouth have been run in split second. That's what deployment is all about. All right. All right. I feel like I've done good today for the introduction. I know like as usual, it's always be vague in the beginning. But with yeah, thank you for your feedback, Karen. It will be vague in the beginning, but if you calm down and learn it, you will understand it. I feel like when we do a hands-on on Friday, you will get to understand it better. Um so any question? The whole house is quiet, man. Hope I was not talking to myself. Oh. If someone to give me feedback, I beg.
You're not, sir. We are here. We can hear you.
Okay, so how far? Any feedback, any explanation? I feel like when you watch the video, everything will sink in, and then you will do the hands-on, everything will sink in. But this is just like an introductory section to what CI/CD is, basically. Yep, yep.
Yes,
So, hello Elijah, I want to say something.
to continue.
I'm done. No, I just need questions and feedback. I'm done.
Oh, my question is now is pertaining to the last class, the last tax.
Ah, okay. Can we answer that here? Yeah, okay.
Okay, I, I have I've done everything, both the back end and front end Docker file. So even when after doing it, the error messages that I got, I've been able to let me say troubleshoot and then got it. But the main issue now is that when I was trying to push it to GitHub, it was showing me error messages that the owner of the repo has not given me permission, something like that. I had
So you know
posted it.
what you know what you're going to do right now.
Yes,
Do
sir.
rm-arrow.git to remove the Git repo. My own
RM.
Git repo. It's very sensitive. It's a very sensitive a very sensitive command. So be very careful. You're going to
Come again.
remove rm-rf.git. You're going to remove my own Git repo. You get,
Okay.
you're going to remove it. You can check in the comment section. You're going to remove it. Then you now reinitialize Git and push.
Okay, sir.
So that one now will be like it's your own document, not as if you got it from me.
Okay,
You
okay,
get.
okay.
But don't do this in production. You're only doing this because you're trying to submit the assignment. Ideally, in production, they will give you permission. You get. But me now, the reason why I cannot give you permission is because the assignment is not mine own, basically, that I created. You get. So I don't
Okay,
know
sir.
how that work. I'll have to go and find the workaround. But as far as you are already done, I don't delay you further. You get. Just do this and push and send the link.
All right, sir. And when I created, okay, I did first, and I created my own repo. So
Yeah.
when I before what was showing, it wasn't actually showing front end folders and back end and all of it. It was showing some other things like the package.json. So it was after I finished everything. So I was trying to push and commit. Then it was showing me that message.
Okay. Oh, well, just push and send. Submit the assignment and get graded.
Okay, sir. Thank you, sir.
Yeah. You're allowed to fork the repo, basically. You're allowed. The repo is yours. Do whatever you want to do with it. Just get me my assignment. If you want to remove the Git, remove it. Do whatever you want to do as far as your own is. But I think there's somebody that did my assignment 100%. Very clean. That one, I can't remember the person's name, but I'll go and find the person. Very clean. Like he showed how when you put a country, it will come out. All those setup very clean. I'll go and look for the person now. I'll point the person out. Very clean assignments. Very clean. Please just try and get everything end to end. Like I said, everything you're teaching in this class is beginner level. So just try. I understand it. Any more question?
Yeah, hello, boss.
Well done. Oh, good evening.
Yeah, good evening.
Okay.
My own is not a question; it's just a suggestion. And
Okay.
then I think most of us that we are learning will be able to learn very well.
Okay.
For the assignment, I don't know if you can find one class, maybe like today or on Friday before we will start, maybe like 10 minutes to do the solution for us so that
Ah,
we'll be able to learn.
Tolewoko,
Uh,
Tolewoko.
maybe uh,
That's why I refer you. That's why I refer you to your classmates now. That's why I refer you to classmates. I'm not in that position to do solution for you. You understand? That's why I always point out people. No, after I say I'll point out this person, ask them, how do you do this bit? That's why I said you are free to ask. You are free to look at their work and do your own. But you are not free to now copy word for word. That's where me and you have problem. But you can ask them, Alpha, make I see your repo. Show me XYZ how it's done. They will show you. Then you do it. So in this class, I feel like there's need to emphasize this. You're not an island in the class. My work is to teach. You will collaborate. You can share repos. Oh, how far? Make I see your repo for this last assignment. You look at the repo, then try and do it your own. I'm not saying that you must figure it out by yourself. No, but the problem I now have is now you collect somebody's repo, copy it, and paste it on your own repo. That's the problem I've been having. That's what people are doing, and it doesn't make sense because I checked this thing. I checked it one by one. If you have 50 submissions, I dedicate weekends to mark most times. That's why when people come and tell me you have not been graded, it's most times people that submit after I've marked during the weekday because weekday is stressful for me. Sometimes I close around 11, 10, 11 because I work remotely. So it's stressful. Right now, as I'm talking to you now, my other computer, I'm watching my monitoring system. That's how it is for me. So weekend like this, when I'm done with everything on weekend, I calm down and I mark. And I go through every submission. So you can ask, I mentioned some guys that are on this. That's why I saw one particular person that I will take note of and drop his name. Meet this guy to help you. Send in your repo, go through it. You may think you have an idea, but when you go through some people's own, new ideas will pop into your head. Oh, okay, this guy used this method, make I use them. Doesn't mean, oh, make I copy him. No, you get. So that's just what it is, basically. We're not allowed to give you solution for tax. We're only allowed to give you the tax. People collaborate. And it's a matter of iron sharpened iron here. You get. So yeah, that's just it basically. Wisdom, did I answer you?
yes, it's okay. Although I have submitted and then you have graded me, but there is something that I could not get. So maybe
That was
I
yeah,
will
that
join.
was I said. Meet guys, send anybody DM. You can tag them. How far were you able to get this? I think you shared his phone number on the Discord. Send him a message and ask. Even if he may not be there to teach you, you can just run it through brief. If you have 10 minutes you're looking for, people are there, you can give you 10 minutes, run it through. If you check their repo, ask questions. Everybody's, you cannot tell me that anybody's repo. I've been checking assignments. People's repo are not private, they're all public. Find them, ask. and then you get the feedback. It's not for me. It's not my place, or rather, it's not my duty to give you solution, basically. You understand? You understand me? Hello, Wisdom, do you understand me?
Yes, I did. Thank you.
No one. Any more question?
Sir, please, good evening, sir. Please, my own is, I want to plead, sir, on behalf of some of us that are still very fast on you, please, and don't just give up on us because we have not given up. Please, sir.
I don't understand.
Thank you, sir.
Did I say I'm giving up on anybody? I don't understand. Am I not
No,
teaching?
no,
I'm teaching
no,
now.
you are, and we are impressed, sir. And
Uh-huh.
we are seeing how far we are from you. So
Hey, you
let
catch
it
up
not be
now.
as
There are
if we are,
videos
yeah,
now.
we are, that's what I'm saying, sir. Let it not look as if we are on serious, sir. Please,
No,
sir.
people are not serious. I like appreciate the
Thank
effort.
you, sir. Thank you, sir.
Mm. So yeah. Any more question? You are not even asking me question regarding what I've talked about so far. You're just asking about previous old things. Old things are passed away, man.
So these ones we will ask question once you start doing them hands-on. Question will be coming.
You, you say so. So yeah.
But make questions not choke you because questions will come plenty.
No wahala now. Any question where you bring where I'm looking answer, I do am as assignment. I know better person Nigerian lecturers. They why me. So yeah. That being said, thank you very much. Let me um, so,